All right, the absolute last page of this amazing practice exam. Matthew starts from rest on top of an 8.45 high sledding hill. He slides down the slick, frictionless slide onto a frictiony part of the problem. And we want to know the distance that he's going to slide here. Oh my goodness, isn't this crazy? So first, let's get the V at the bottom. So here we go. I'm going to actually, so I'll call this part region 1 and this part region 2. In region 1, let's get V at the bottom. So we're going to have all this mgh gravity energy getting converted to 1/2 mv squared energy. I have to be honest, I borrowed this problem from a friend, and I absolutely hate these numbers. Why would we choose 8.45? All right, I've committed all of us to this course of action, so 8.45 it is. Since we're in honors, I'm just going to sassily cancel these m's here because they divide out. So we have 10 times 8.45 equals v squared over 2. Here we go. We're going to get 9 point something for this, aren't we? No. So, yeah, actually, let's see. So we'll get 84.5 equals v squared. Whoa, gross. I don't like it when it writes that way. 84.5 equals v squared. And our v is going to work out to, gosh, I can hardly wait to figure out what the square root of 84.5 is. 9.2. I'm going to round. Try and stop me. You can't because you're just watching this video. All right, 9.2 meters per second. Now, here's the deal. For part 2, to get the distance, what we're going to do is we're going to basically use the work done here. So what we're going to say is that the E dissipated, so basically all of this kinetic energy is going to become E dissipated. And then we're going to use the E dissipated to get the work done, which is the friction force times the distance to stop. So step at a time, 1/2 times m, which is 65, times v squared, which works again out to 84.5 when I look at part 1. That's going to be E dissipated. All right, everybody, try to contain your amazing feelings of enthusiasm as I calculate this out. Yippee. 2,746 joules. That is some major joules there for a physics problem of this caliber, I guess. Not really. It's typical. We're talking about a 65 kilo person, so that's not surprising. So this 2,746.25, that's the E dissipated, is going to equal the friction force times the distance we slide. Let's get that friction force. So friction is mu times n. So let's put little Matt right here. Here you go, Matt. You're on the snow. Okay, let's draw a free body diagram of you, buddy. Well, you've got your normal force and you've got your weight. So what does this tell me? Normal is the weight. Sorry, I was just writing wrong. So normal equals Fg, which is going to equal 65 kilograms times 10. So the friction force ends up being 0.128 times 650. It's going to be about 90 something. Let's see, so. Now close, 83.2. 83.2 newtons. That's not a lot. I like that. It's going to equal 83.2 times the distance. Ooh, we're going to slide for a while, aren't we? So So that's given us 33 meters. Wow. That's not bad, a third of a football field, 33 meters. So for those of you that go to college in the Midwest, or if it ever snows, you can get like the cafeteria trays. And you probably do this in Tahoe, but if you spray the bottom of it with cooking spray, you reduce that friction coefficient even more. Just a little bro tip there. Okay, I shouldn't have said that. It's just I'm not a bro. Anyway, so we get 33 meters worth of distance, and that's it for the very last problem on this test.